Okay. So what concept we are discussing? Stats, right? So let's see. In the statistics, we are into the descriptive statistics. Okay. So let me open those things. Just give me a minute. Let me open the files. Stats. Okay. So guys, okay. So where are we? We completed what is the sample data, population data, mean, median, mode. We completed the range. We completed the percentile, quantile. So these things completed, right, everyone? Yeah. So these things we have completed. So now I will be telling you about outliers concept along with the interquartile range. So very, very important. Then we will see the variance and standard deviation also. So let's come down here. Let me write. You can see my screen at everyone. Please confirm me, everyone. So yeah, clear. So yesterday we have seen the quantiles and everything. Now let's say what is the meaning of outlier generally. So for example, what is the meaning of a outlier? Outlier means the value which is far away from the remaining value. Okay. So let's say outlier. Outlier means the value which is far away, far away from the remaining values, from the remaining values. So what is the meaning of it? What is the meaning of it? So for example, say guys, if you have a data, let's say if you have a column known as a column known as an age column, where you are having the value something like 2, 4, 6, 7, 9, 5, 11, 12, 42. 42. Then you see the values, if you see here, how beautifully they arrange. So the values which you are seeing here are close to each other. But there is a one value which you see here. This value is completely far away from the remaining values. Am I right?
Yes, sir.
Yes or no? So let's if I make a circle, okay, if I just make a circle and let's say if I write the points, for example, so the this point belongs to 2, 4, 6, 7, 9, 5, 11, 12. Everything will be close to each other. But the 42 point will be far away. Yes or no?
Yes, sir.
So see, outliers completely change the data intuition. So it will affect a lot. For example, why it will affect, sir? See, if there is a there are few values here which you are seeing. So if you find the mean for these values, if you find the mean for these values, will be close to the particular value. If you include the 42 also, the complete mean will change. Yes or no? You will be getting a bigger value. Yes or no? You will be getting a bigger value. If you are changing in the mean means the average only changing. So the complete intuition about the data changes. So outliers is one of the most important concept to handle. So for example, outliers. See, if I show the outliers, what is the meaning of outliers? An observation, which means a point that lies an abnormal distance from other values. Okay. So the value which you see, for example, any image you take, for example, any image you take, let me pick suppose this value, this image. You see here, there are few points which are close to each other, but these two values are far away. So these two are outliers. These two are completely outliers. So a lot of people, what they will do is, I mean, the beginners people, they will remove these 2 points. So see, as a data scientist, as a data analyst, data is very important for us. Okay, data is very important. If you remove the data, if you just remove the data, for example, if you remove the data, is a good option?
No.
So if you remove the data means it's not a good option. You need to handle the data. If there is outlier, use the techniques, stats techniques, use it, and you need to handle the data. You should not remove the data. Okay. So as a data scientist, how you are going to handle these outliers? Mainly these outliers will be done by the data scientist. Okay, because a lot of math intuitions will be there. So I will be explaining you from the scratch. Let me pick, for example, I am here now. I am here. So we know we have the Titanic data set. If you remember, we are having the Titanic data set. So what I will do is I will first of all see, I am going to import the NumPy and I'm going to import the pandas. I'm going to import the NumPy and I'm going to import the pandas. Okay. See, all the advanced level of statistics can be done only with the help of Seaborn. So I want a Seaborn library. I will zoom it if needed. The code. Okay. Yeah. So I'm going to import Seaborn as SNS. I'm going to import the Seaborn library. So before that, first, I just want a data set. I just want some data. So let me take the data manually and let me explain. Then we'll apply on the some data set. Suppose let me take a data set. Let me take a data. Let me set some data here. And I'm treating them like a age column, for example. I will treat them like a age column. So I will write the data here. In a column, I will write the data. So in a column, let's write some data, whatever the data that we want. Let's write that particular data. And how you are going to handle the outliers, let's see. For example, I have the data. Just imagine I have the data something like 1, 2, 2, 2, 3, 3, 4, 5, 5. Guys, are you noting down all these things in the notebook or are you just keeping in the mind?
We're noting down.
6, 6, 6, 8, 8, 9, and 27. For example, suppose imagine this is the data which is present in a column, which is present in a column. So these data, this data is having outliers or not. How you will find out? How you will find out? How to see whether in the particular column outliers are there or not? See, so if I do the visualization something like this, if I do the visualization something like this, see, this image is known as a box plot. This image is known as a box plot, and in this box plot, whatever, if the values are here and if the values are this side or this side, those things will be treated as outliers. Okay, these kind of data points will be treated like outliers, which means far away, which means very very far away, very very far away. So you do one thing. What you have to do is, first of all, this is the data. Okay, this is the data. First you need to find out. First you need to find out what values are known as a outliers. Like in this data, what values are outliers and how the image is understanding. Let's see, I will directly implement. I will directly implement, but you can't understand directly. Let's say, suppose see, df is equals to pd dot data frame. I'm going to apply the data frame. I'm going to apply the data frame. I'm going to take the column name as age, and I'm going to pass the same data which I have written here. Same data I will pass it here. Same data I will pass. Okay. So these are the data I'm passing. So I'm passing this data and I'm printing the DF in front of you. I'm just printing the DF in front of you. See, this is the data. So lot of people, what they will do is, whether this data is having, whether this data is having outliers or not. I mean outliers or not. So what they will do is, generally directly any student, what they will do is, just give me a minute, I will close my WhatsApp. Yeah. Okay. So in this particular column, you are having the outliers or not. Simple logic. So to prove the outliers, what is the visualization tool that we need to use? Box plot. We need to use a visualization tool that is known as a box plot, where box plot will be available in the Seaborn. I told you advanced level of stats will be available in the Seaborn. So SNS means Seaborn. In the Seaborn, okay, in the Seaborn, I'm going to use a plotting. In the Seaborn, there is a, see here, second one, box plot. In the Seaborn, there is a visualization called box plot. So for this box plot, I'm going to give this data. I'm just going to give this data, which means age column. I'm going to give the age column to the box plot. To the box plot, see, I'm going to give the age column, df of age, because the data is present in the variable df, and I'm going to give them to the age. So df of age. Simply, if I run it, so it is going to show some visualization for me. It is going to show some visualization. So you can decide the output image sizes or no. The output image size also you can decide. How? Import matplotlib dot pyplot has plt. How guys? Plt dot figure of pick size. The output size I just need something like 5 comma 5, for example. So let's say plt dot figure of pick size equals to. So see, this is the size. I just want to reduce the height, and I just want to reduce the height, and I just want to increase the width. Increase the width. Okay. So see, this is how it is showing. So can you see a mark here, guys? Can you see a mark?
Yes, sir.
So what is this? It is an outlier. My point is, generally any student will show me in the data there is an outlier, sir. Okay, fine. There is an outlier in the data. In the age data, there is an outlier. What is this point? What value this point belongs to? How this visualization is coming? Nobody knows. So let's deep dive into that. If you want in a reverse order, if you want the visualization in a reverse order, so let's take in the x-axis. Suppose in the x-axis I need the visualization. So it comes like this. See, there is one point which is staying far away. So what is this point? What is this visualization? Let's understand and let's deep dive into the concept. Okay. Suppose this is the data. Suppose this is the data, and you are going to learn a concept which is known as a box plot, outliers box plot. So you are going to learn a concept which is known as an outliers box plot. Outliers, you can understand the outliers using a plot known as a box plot. Okay, box plot. Okay, so see, box plot means what is how the box plot looks like. The box plot looks like something like this. This is how the box plot looks like. What is the meaning of it? What is the meaning of it is, this is known as an lower area. Lower area. This is known as an upper area. Okay, upper area. So in the middle also one line will be there where this is the median. Where this is the median. So this is the 75 percentage of the data. Where this is the 25 percentage of the data. So generally the meaning of this visualization is lower area, upper area, median, 25 percentage of the data and 75 percentage of the data. So in any Google, in the Google, if you see, it looks like this. Let's say it looks like this. Let me write here clearly. So you will be seeing something like this. You will be seeing like lower area, lower area. This you will be seeing something like upper area. This is 25 percentage of the data, 25 percentage of the data in the column where you can represent them with Q1, where you can represent them with Q1. So this is 50 percentage of the data, which is median, where you can represent with Q2. This is 75 percentage of the data, where you can represent with Q3. Okay, so I will explain each and every point, no worries in that. So what is this 25 percentile, 75 percentile, all those things? Let's see. So first we have the data, this one. So this is the data now. So in this data, what I'm going to do is, first in this data, in this data, please find these two areas. See, in the age column, I want to find out 25 percentile data and 75 percentile. So first let me find out 25 percentile data in the age column. I think yesterday I told you about 25 percentile data, how to find out the value which is present exactly at the 25th percentile. Did I teach you yesterday? So 25 percentage, what is the formula? 25 divided by 25 divided by 100 into n plus 1. The formula you can see on the top, n plus 1. Total how many values? 3, 6, 9, 12, 15, 18, total 19 values. 19 plus 1, total 19 values, n plus 1 concept. No? 19 plus 1 is nothing but 19 plus 1 is nothing but 20. Okay, so 25 divided by 100 into 20. So cut the 0, ones, what you say, 5 twos are 5 fives are 5 twos are 5 fives are. Okay, next 5 twos are 10. 10 divided by 2, how much you will get? You will get 5, yes or no? You will get 5. So this we need to treat like index, am I right? Yes or no, guys? This we need to treat like index. So what is the fifth index value? 0, 1, 2, 3, 4, 5. In the fifth index, what value I am having? In the fifth index, what value I am having? So for the 25 percentage data, I got a answer which is 3. Done. So 25 percentage completed. Solve the 75. 75 percentage data is equals to 75 divided by 100 into 19 plus 1. Please solve it. So which means 75 divided by 100 into 20. So you will be getting 0, 0 cancel. Let's say 2s are 5 2s are 5 15s are, I think. 15 2s are 30, 30 divided by 2. You will be getting how much? 30 divided by 2. You will be getting 15. At the 15th index position, what is the value count? This is 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. What value you are having? 8. You are having 8. 15th will be treated like index. Okay. 15 will be treated like index. So for the 75 percentage, what value you are getting? For the 75 percentage, what you are getting? 8. So these both are important. Okay. Okay. See here, just check the visualization. So they are asking to find out 75 percentile data, which means Q3, 25 percentile data, which means Q1. Okay, we find out these two. We find out these two. Next one, what you have to find out? The difference between these two. The difference between these two area. Q3 minus Q1. The difference between these two is nothing but Q3 minus Q1 is known as an IQR. If anybody asks you what is the meaning of IQR, interquartile range. So what is the meaning of interquartile range? The difference between 75% of the data minus 25% of the data, which means Q3 minus Q1, which means Q3 minus Q1. So please solve it. What is the IQR? What is interquartile range? What is interquartile range? So IQR means Q3 minus Q1. Let's say Q3 minus Q1. Q3 means 75, Q1 means 25. 75 means how much? 8. 8 minus Q1 is how much?
3.
3. 8 minus 3 how much?
5.
5. So what you are getting IQR? IQR you are getting 5. Clear now? Till here?
Yes.
Yes, sir.
Okay. 75 percentage, 25 percentage IQR we are finding. Next, what you want to find out? You want to find out the upper area and you need to find out the lower area. What is this? These are stable formulas, guys. These are stable formulas. How you will find out the upper area? Let's first upper area. Upper area formula is what? See, upper area formula is nothing but upper area formula is 75 percentage of the data plus 1.5 into IQR. This is the general formula. This is the general formula, which means from here we are going to travel to some location, to some extended location. So see, 75% of the data plus 1.5 into IQR. If the data is very big, in the place of 1.5, we will take 3. In the place of 1.5, we will take 3. But as of now, we'll go with 1.5 because we have very small data. What is 75 percentile of the data? What we got for the 75 percentile?
8.
8. So 8 plus 1.5 into what is IQR? 5.
5.
5. So if you solve this one, what you are getting? If you solve this one, can you please tell me, anyone? If you solve this,
15.5.
sorry,
15.5.
10.5.
15, 1.5.
Okay, 15.5. 15.5 is the upper area. 15.5 is the upper area. Let's go with the lower area. What is the formula for the lower area? Okay, so 25% of the data. See, lower area means 25% of the data minus you are going to the back side minus 1.5 into IQR. 1.5 into IQR. So what is 25%? What value we got? I think 3, right?
Yes.
So 25% we got 3. So 3 minus 1.5 into 5. So what you will get here?
0.3.
Sorry, 0 minus 0.
0.5.
Minus 0.5 or 0.5?
0.5. Because it's 3 minus 1.5. And the 3 is the bigger number.
Okay, so I'm just asking. So what is a 5 into 1.5? 7.5, I think. I don't know exactly.
Yes, sir.
So here 7.5. Okay. Then you solve this one. 3 minus 7.5, how much?
Minus 4.5.
Minus 4.5. Okay. So this is the result and this is the result. Come on. Now everyone, please note down the values. Please note down the values. So what is 25% value you got? 3.
3.
What is 75% you got?
8.
8.
8. What is IQR you got?
5.
5.
What is IQR is nothing but 5.
5.
Okay. IQR is nothing but 5. Okay. Next one. Next one. What is upper limit we got? 15.5. What is lower limit we got? Minus 4.5. What is, okay? Minus 4.5. Then one more thing just we missed. One more thing we have missed. Let's say, see here, a lot of people will do one thing. For example, median. See, what you do is find out the median for this. For this data, what is the median? Can anyone tell me? What will be the median? So let's say, so total how many values are there? 19 values, right? Total 19 values. So it's an odd. So odd means, let's say 9 values I will take aside. Total 3, 4, 5, 6, 7, 8, 9. 9 values aside. And these 9 values aside. Am I right?
Yes, sir.
9, 9, 8. Middle one is 5. Middle one is 5. IQR, what you are getting? 5. Same or
5.
not? Because the
Yes.
difference between 75 and 25 is nothing but 50% median. Yes or no?
Yes.
So you can treat IQR like a median. So this is the result I got. From the data using the formulas, I find out this one. What is the meaning of this result, Kamal? What is the meaning of this result? The values which are less than minus 4.5 and greater than 15.5 are outliers. Are outliers. Simple. Okay. The values which are less. Just give me a minute, guys. Sorry, guys. So the values which are less than minus 4.5 and greater than 15.5 are outliers. Simple. Okay. So now in this data, do you have any values which are less than 4.5? No. But more than greater than 15.5, you have 27. Yes or no?
Yes.
You have 27. So now what I will do is, I will take one line here. I will take a line here. Okay. In this line, what I will do is, so according to the lower value and upper value, what I got, so I will write something like this. Minus 2, suppose, let's say 0, let's say 2, let's say 4, let's say 6, let's say 8, let's say 10. Suppose some axis I'm writing. Let's say 12, let's say 14, let's say 16. Okay, so point by point will come. Point by point. So what is the lower limit? Lower limit is minus 4.5. Okay, keep it aside. Lower limit is keep it aside. So the values which are less than minus 4.5, greater than 15.5 are outliers. So in these data, what is the minimum value? In these data, what is the minimum value?
1.
1 is the minimum value, yes or no?
Yes,
So
sir.
in this data, so what you have to do is, first of all, what is the minimum value we have? Minimum value is 1. Minimum value is 1. What is the max? Okay, minimum value is 1. So wherever where the 1 will come here only, no? I'll make a dot.
Yes,
Okay,
sir.
I will make a dot. So what is the 25 percentile value? What is 25 percentile value? 3. So the 3 dot I'm keeping here. Okay. Next, what is 50? What is IQR? I know. I mean median.
5.
So
Yes.
I'm making here. Next, what is 75 percentile?
8.
8. 8 means somewhere here. Yes or no?
Yes.
8. Okay. What is the maximum value in the data? Maximum value is 27.
Yes, sir.
Maximum value is 27. But the 27 is greater than 15.5. So it's an outlier. Yes or no?
Yes, sir.
So irrespective of 27, what is the maximum value? 9. Am I right?
Yes.
So 9 is the maximum value. 27 somewhere it will be here. The point is here, which is 27, which is an outlier. Which is an outlier. Okay. So now what I will do is I will make the lines like this. Okay. I will make the lines like this. Okay. So what I will do is I will connect them. See, you got the box plot or not?
Yes.
So this is the box plot. So for that particular age data, you are getting the box plot where you are finding the outlier. 27 is the outlier with the proof. Now go to the visualization which we have done. Come back here. See. See here. What is this point in the data? 20.
Yes, sir.
You understood?
Yes, sir.
Okay. So this is 25 percentage, 75 percentage. Difference between them is IQR. So here upper limit. This is lower limit. I mean the minimum value, not upper limit and lower limit. Minimum value and the maximum value from the data. Minimum value and maximum value from the data. The values which are less than the lower limit will be treated like outliers. The values which are more than the what do you say, upper limit will be treated like outliers. 27 is a point which is completely an outlier. Now I think you got what is the meaning of this visualization and what is this point. So if you just do the visualization and if you say in this data one data point, you won't get the job, I'm telling you. So interviews will be not so easy. So they will ask you what is the meaning of this visualization, how this point is coming. So the entire pure implementation is here, entire concept. Understood, guys?
Yes, sir.
Understood. Okay. So what they will do is generally, lot of students they will remove this value since outlier will affect my data. They will remove this value. But I'm telling. So what I'm saying is the value which if you remove the value, you will be losing the data. So you should not do that. Then what we have to do? Handle the data. Handle. Handle it. Handle the outlier. So how you will be handling? How you will handle them? So what we will do is I will write a logic. We call them as capping concept. Lot of concepts are there: capping, skipping, let's say standard deviations, ninth standard deviations, 15th standard deviation. Those things in machine learning I will tell you, but one of the concept I will teach you here: how to handle the outliers. How to handle the outliers is nothing but, let's say, a simple logic I will write. What logic I will write? The values. See, capping concept means the values which are less than lower limit. Lower limit, convert them into lower limit. Make them into lower limit. Okay, lower limit or a minimum value. So the values which are more than upper limit. More than upper limit. For example, what is the maximum value here? What is the maximum? See what we are writing. 15.5. 15.5 is the maximum value. I mean upper limit. Minus 4.5 is the lower limit. The values which are greater than 15.5 are outliers. Okay, are outliers. So what I will do? The values more than 15.5, more than upper limit values, convert them into upper limit. Upper limit. What is the logic here is, here clearly mentioned, the values which are more than 15.5 are outliers. So if I convert this data point to 15.5, do we have any outliers? Do we have any outliers on the time? See, the values which are more than upper limit, 27 is more than upper limit. If I convert that outlier into upper limit, like 15.5, we solve the issue, no? We have solved the issue. So we need to convert 27 to upper limit, which is 15.5. Guys, got it? What I'm going to do?
No, sir.
Okay. So see, what I'm going to do is we have an how many outliers are there currently?
2.
We have only one outlier, which is 27. We have one outlier. The concept, capping concept means the values which are less than lower limit are outliers. See, less than lower limit means there are outliers, greater than upper limit means outliers. So
Yes.
if there is any value which is less than minus 4.5, I will convert them into minus 4.5. The values which are more than 15.5, 27 is a point which is more than 15.5. I will convert this into 15.5.
Yes.
Okay, then now tell me 27 point becomes 15.5. Now in that case, do you have the outlier?
No.
No.
So we are going to convert the values. So those things I am going to do here. See, handle outliers. Okay, handle outliers. So how I am going to handle the outliers? See, simple logic I will tell you. So in the age column itself, see for example 27 is there now, which is in the age column. Df of age, the variable is df and the column name is age. So see, simple logic, using numpy, I'm going to use a function known as a where function. So where function, numpy dot where, in the age column, the values which are more than 15.5, which means upper limit, So using NumPy, wherever in this particular column, wherever each value it will take, first value it will take in the each column. First value it will take, it will check whether it is more than 15.5 or not. Second value, third value, fourth value. Whatever the values in the age column which are more than 15.5, I am going to convert them into 15.5. 15.5. So the values which are more than 15.5, make them into 15.5, which means 27 will be converted to 15.5. Comma, come down here. Again, np dot where in the age column, the values which are less than minus 4.5, make them into minus 4.5. So the values which are less than lower limit, please make them into lower limit. And but what about remaining values, guys? If there is outlier, we are converting into upper limit. If there is any outliers here, converting them into their lower limit. Remaining data as it is, we need to maintain. Yes or no?
Yes, sir.
Remaining data. So remaining data, I'm going to keep as it is. Remaining data, I'm going to keep as it is. So what was the logic? In the age column, the values which are more than 15.5, make them 15.5. The values which are less than minus 4.5, make them minus 4.5. Or else remaining data keep as it is. Keep as it is. All this content I am doing, and I am updating in the variable df of age only. In the age only. Or else you take another column. So let's say I'm going to create a new column, changed column. Okay, I'm going to create a new column. Okay, what I'm going to do? I'm going to create a new column which is age changes. So in the age you have this data, and in the age changes a new data will come. Let me run this script. Let me run this particular script. See, it is running. Now if I show the df in front of you, you will be having two different columns. So one is age, which is the original one. Age changes. So there is no minus values, so there is no need of that. But see, 27 changes to 15.5 or not.
Yes, sir.
Yes or no? So now if you see, if I apply the box plot, so df4, so sorry, using the C1, I'm going to apply the box plot for the particular column. What is the column? Age. See, age changes. For this column, I'm going to apply the box plot. Now if I'm going to show, just give me a minute. Just showing the age changes. So just give me a minute. So its changes now should not come. Just give me a minute, guys. Let's solve it. There might be some issue. So this is the age column. This is the age column. So what is the next another column, that updated column? Age changes. See, here some logic we are missing. You are directly writing 15.5. So some kind of decimal values will also come now here. Generally, if you do proper mathematics. Okay, so that might be the issue. So I will do it, no problem. Age underscore changes. Age underscore CHANGS. On the new column also, if I am applying, the outlier is like that only. What is the issue? So let's do one thing. First, I am taking the data. I mean, see, normally the original data, age data, which we are having the outliers, you can see. Okay, and we are doing the mathematics here, and we are implementing directly values, but not, I won't do like that. So what I will do is upper limit. I will find out upper limit here. Even the floating values also I don't miss. Upper limit. So in the age column, what is the meaning of upper limit? 75 plus 1.5 into IQ. Am I right?
Yes, sir.
Am I right? So in the age column, please find the quantile of 75 percentage plus 1.5 into, first you need to find the IQR. Yes or no? You need to find the IQR. IQR means what? What is the meaning of IQR?
Enter
75 minus 25, yes or no? So
Yes.
IQR is equals to in the age column, so QUANTILE quantile 75% of the data minus in the age column quantile 25% of the data. 75% minus 25%, you will be getting IQR. See, you will be getting IQR, proper IQR for the data. So some kind of floating kind of things we might miss. We will be getting, see, for this data 3.5, exactly 3.5, we are getting the IQR. Okay, I'm telling you, each and every floating value calculations also will be done by the CPU. Okay, so concept is same. The same concept will be implemented there. But we will completely missed all the floating values. Keep it aside. So we are getting IQR. So what I'm going to do, what is the upper limit? DF of age, 75% of the data plus 1.5 into how much less? 1.5 into IQR, yes or no? What is the meaning of IQR? We are already having the IQR value. So we will be getting upper limit value. Upper limit. So let's say lower limit. So I'm going to find the lower limit is equals to in the age column QUANTILE quantile of 0.25% of the data minus 1.5 into IQR into IQR. So we will be having print lower limit. Okay, sir, why we are getting a huge differences? Because see here it will take the direct value. We are going with the index. Lot of things will be there on the back end. Version to version they will change. Okay, so see what is this? Sorry, here minus. Okay. Okay, see, this is the IQR, this is the upper limit, this is the lower limit. Why lot of differences? Here it checks the values, floating value concepts will be done, all the things will be done. So now what I will do is, this is IQR, upper limit and lower limit. So in the age column, the values which are more than upper limit, which means 11.5, 11.75, please make them into upper limit. Okay, the values which are less than lower limit, please make them into lower limit. Guys, following me? Lower limit. The values which are more than upper limit, making upper limit, which are less than lower limit, making lower limit. Remaining things I'm keeping as it is, and I'm saving in a new column. Now I'm going to show the data in front of you. See, this is the old one, this is the new one. So old one is having the outliers which you can see here. Old one is having the outlier which is 27. So come down for the new one. Let's say for the new column, for the new visualization, if I apply, see here, can you see anything? Can you see any outlier? Can you see any outlier here? Outlier has been handled or not?
Yes, sir.
Okay. So there is a different ways, standard deviation ways, third standard deviation, seventh standard deviations. Lot of things are there. So this is how we will handle the outliers. I hope you got it, everyone. The backend mathematics, how it will apply, how it will understand the data, and manually how you need to implement the concepts. Stats implementation is very, very, very important. Don't think statistics won't be asked in the interviews. They will ask you to write the code.
Sir,
Yeah.
every time we are taking that 15.5 is main upper limit and minus 4.5 is the lower limit. In every data, these are the
No, no,
upper
no.
limit. And,
No. How it will be for every column? It will be different, na?
yeah. That's why
Okay,
I'm
column
asking.
wise. Yeah. Column to column it changes.
Okay, sir.
Okay. Simple. Understood now? Outliers concept.
So we need to show the outlier or not. We need to handle it.
You need to show the outlier, and after showing the outlier, you need to handle. how you are handling, what report you make, everything you need to do.
We have to do the both.
Yes.
Okay. Thank you, sir.
So next one is variance, for example. What is the next one? You clear now, everyone? Outliers concept.
Yes, sir.
So variance and standard deviation. Very, very important. Variance and standard deviation. See guys, for example, let's say, first of all, I will write the formulas for this both, for the population and for the sample. So let's say, variance for the, I will write here, variance for sample, for the sample data, what is the, for the sample, what is the formula, for the population, what is the formula. Okay, and for the standard deviation, what is the sample formula and what is the population formula. See, variance means variance will be represented with the help of sigma square. Sigma square. Okay, variance generally it will be replaced with sigma square. Instead of writing like this, let's say individually, let me write, then it will be much more easy to understand. Okay, let me first go with the variance. So variance, okay, variance with the population data. With the population data will be represented with the sigma square. Will be represented with sigma square. Sigma square is equals to each and every data point minus each and every data points minus its mean whole square divided by capital N. Capital for the population data. Capital, this is the formula. This is the formula for the population data. Variance population. Okay. So let's say standard deviation population formula is what? Just you need to shift the square to right side. Just you need to shift the square to right side. So which means sigma is equals to root of each and every data point minus mean whole square divided by n. Divided by n. Okay. This is the population. So variance with sample data. Variance with sample data. So let's say sample data. S square is equals to each and every data point minus its mean whole square divided by n minus 1. Standard deviation with the help of sample data. S is equals to shift to the square root each and every data point minus its mean whole square divided by n minus 1. Guys, concept is same. Here mu means mean, here x means mean. Simple. Okay. So representations will be different. This is with the sample data formulas, and this is a population data formulas. Okay. Population data formulas, sample data formulas, and population data formulas are very important. I'm telling you. So what is the difference between them? What is the meaning of this? I will give you the best example. Guys, let's see, if you want to understand the standard deviation and the variance properly, I will give you one best example. I will give you one of the best example. Imagine who is your favorite cricketer in India? Let's take Kohli and let's take Rohit Sharma. Okay. Suppose let's take Kohli. Okay. For example, Kohli and let's say Rohit Sharma. Rohit. So the BCCI are in plans to make the captain any one of him. Already they are captains, but see, just I'm telling you. So I want to make any one of the captain. So generally what I will do? Generally what, if I want to make any one of him as a captain, the last few match performance we will record. Yes or no? We will note down last few matches record. Am I right?
Yes, sir.
So let's write the matches. Imagine Kohli, last 6 matches I will take. So last sixth match, 33 runs he is doing, 31, 32, let's say 36, let's say 31 runs, 31 runs. So last 6 matches runs I am writing. Similarly, Rohit Sharma also Last 6 matches runs I am writing here. Last 6 matches runs. Okay. Let's say 52, 10 and 20. 10 and 21. So who will, based on these values, who will be the captain? We can't guess directly. Rohit Sharma will be the captain. Okay. Rohit Sharma will be the captain because he is going high, high, high. Okay. So this is the data I want to make sure who becomes the captain. So in that purpose, we will use the variance. So first I will use the variance on top of Kohli. On top of Kohli. Okay, understand the concept, guys. Okay, Kohli. So Kohli variance, how you will find out? What is the formula? Sample data formula. So each and every data point minus its mean whole square divided by n minus 1. So first what you have to do, you need to find the x bar, which means mean. How you will find out the mean? Add everything, 33 plus 31 plus 32 plus 36 plus 31 plus 31 divided by 6. Divided by 6. What you will get? You will get a value. Okay. You will get a value. If anybody have the patience, can do the mathematics.
194 maybe.
33, 30, 63, 64,
194 by 6.
194 by 6. 3s are 1, 2s are 2, dot 0, and if I write 8, I think 3. 32.3, I'm right?
Yes, sir.
32.3. So 32.3 we are getting. So we are getting 32.3 mean value. So apply in this formula each and every value in the Kohli. So 33 minus 32.3 whole square plus 31 minus 32.3 whole square plus 32 minus 32.3 whole square. Each and every data point minus its mean whole square. Let's say 36 minus 32.3 whole square plus 31 minus 32.3 whole square plus 31 minus 32.3 whole square divided by n minus 1, 6 minus 1, number of values minus 1, 5. Imagine if you do the math calculation, you would get a value. You would get a value. So suppose, imagine I'm getting some value. I'm getting some values. Let's say I'm getting the variance value for the Kohli. I'm getting, suppose I'm getting, what you will get, let's say I'm taking something like 18.5 for example. I'm taking 18.5 for example. I'm taking, okay, same thing. If you do the standard, let's say same thing you use for the Kohli. Rohit Sharma. Same concept you implement for the Rohit Sharma in the same formula. Imagine you are getting something like 31.5. So now tell me who will be getting the highest? Who will be getting the captaincy? According to the values, you will choose Rohit Sharma. Yes or no? Because
Yes.
Rohit Sharma is getting highest one. But using the variance, we should not decide. So see, why sir? Why means, see, you need to use the standard deviation. So if you use the standard deviation, okay, if you use the standard deviation means whatever the result that you are getting, you will apply the square for it. Suppose imagine if you apply the standard deviation, for the Kohli, suppose if you are getting 3.2 and the standard deviation value for the Rohit Sharma, if he is getting, let's say 12.4. So now tell me who will be the captain?
Rohit Sharma.
Kohli will be the captain. Why? Because what is the standard deviation of Kohli? 3.2. What is the standard deviation for Rohit Sharma? 12.4. Which means on an average, Kohli is doing how many runs? On an average, 32.3 runs he is doing, definitely. So in the next match, he will do plus 3.2. He might do 35 runs, or else he might do 28 runs. Okay. So on an average, he will beat 30 to 40 runs. Yes or no?
Yes.
On an average, he will beat 30 to 40 runs. Let's go with the Rohit Sharma. What is the Rohit Sharma mean? Suppose Rohit Sharma mean you are getting suppose Rohit Sharma mean you are getting 80. So sometimes he will beat 92, or else sometimes he will beat 0. In Australian grounds, he will make 0. In Indian grounds, he will make 120. So fluctuations are there, sir, no? So based on the standard deviation, we will decide who is doing the perfect weights. That is a small difference between variable and standard deviation. So how the standard deviation will be noted? How the standard deviation will be noted down? See, for example, I will take some values. Let's say I will take some values here. For example, I am taking 1, 4, 7, 3, 2, 8, 6, 4. Suppose 6, 4. So if anybody ask you, no, don't go with the variance. Variance is useless. Go with the standard deviation. How the curve will come, standard deviation, how the standard deviation line will come. How the standard deviation line will come. Let's say first to find the mean. First to find the mean. What is the mean of this data? What is the mean of this data? 5, 5 plus 7, 12, 15, 17, 17, 25, 31, 35. 35 divided by how many values?
8.
8 values. 8 values. What is the answer?
4.8.
4, and we will be having 3. 4.3.
3.
So 4.3 is the mean. So in the place of mean, I will write 4.3. 4.3. Okay. What is the standard deviation of this data? Standard deviation of this data. Sir, it is very complicated to find out. Why to waste the time? You just remind me these numbers 1, 4, 7. See, I will go here. I will go here. So suppose let's say within minutes I will do it. A is equals to pd dot data frame. I'm going to create a column. Suppose a column name is X, and I'm going to pass that values. What are the values? 1, 4, let's say 7, 7, 3, 2, 8, 6, 4. 3, 2, 8, 6, 4. Total 8 values.
Yep.
Okay. So see, sir, I want to find the standard. We know the mean. We already got the mean. What is the mean? Say A dot mean. Simply, I will apply the mean. I will get the mean value. So this is the mean, 4.3. Okay. This is the mean. A dot STD, standard deviation. See, all the mathematics will be done on the back end. So this is the standard deviation. So 2.4 is the standard deviation. So what is the standard deviation? 2.4. What is the relation, sir? See, this is the mean. From the mean, the first standard deviation, second standard deviation, third standard deviation. Okay. First standard deviation means, let's say, okay. So 4.3 plus 2.4. What value you will get? 6.7, right?
Yes, sir.
6.7. 6.7. 6.7 plus standard deviation 2.4. 9.1, I think so. Right? Okay. So 9.1 plus standard deviation 2.4. 11.5. Okay. 3 from the mean position, 3 standard deviations. 3 standard deviations. Negative side, 4.3 minus 2.4. You will get a value. What value you will get? 2.1 something. So 2.1 minus 2.4 minus 0.3. And again, last one,
1.9.
something, just I'm writing randomly.
Okay, sir.
Minus 0.3 minus 2.4. Suppose imagine you are getting minus 2 point something. Okay. So if you go to the internet, if you see here, if you see the STA and DARD standard deviations, let's go with the standard deviation. Let me open the standard deviation images, any one of the standard deviation images. Let's pick this one. Let's pick this one. Okay. So can you see here on the x-axis there are some values which is mentioning here. Okay. Okay. Which is mentioning here. So what is the meaning of these values? For example, same thing I will implement. Imagine you have a data. For example, imagine you have a data. You have a data and the data mean is 0 and standard deviation is 1. Okay, standard deviation is 1. So the interview person asks you to write 3 positive standard deviations, 3 negative. Mean how much? 0. So 0 plus 1 is how much? 1. 1 plus standard deviation is 1. 1 plus 1 is how much? 2. So 2 plus 1 is how much? 3. 0 minus 0 minus standard deviation. 0 minus 1 is minus 1. Minus 1 minus 1 minus 1 minus 2. Minus 1 minus 2 minus 3. Same thing you are getting or not?
Yes, sir.
See, in your data, your mean is 0 and standard deviation is 1. It comes like this. But in your data, your mean is 4.3 and standard deviation is 2.4 means this will come. What is the use, sir? See, exactly, if anybody asks you where this 8 is there, come on, where the value 8 is there. So the value 8 present from in between first positive standard deviation to second positive standard deviation. In this area, the value 8 is there. In this box, the value 8 is there. This is negative side. This is positive side. Understood this? Understood? How the standard deviations variances will be calculated on the plane. So there is a lot of use with the standard deviation. You might ask me, sir, what is the use of the standard deviation? See, let's say there is a concept. There is a concept known as an normal distribution. There is a concept known as an normal distribution. Okay, normal distribution means first, see, normal distribution means same, the mean and the standard deviation line will come. The mean and the standard deviation. Suppose this is the mean, this is the first standard deviation, this is the second standard deviation, this is the third standard deviation. This is negative side standard first standard deviation, this is the negative side second standard deviation, this is the negative third side standard deviation. Okay, negative side and positive side. See, normal distribution means in between in the first standard deviation, I told you entire column data will be treated like 100%. Yes or no? 100%. So in the first standard deviation from the negative side to positive side, in the first standard deviation, if your column following the bell curve, if your column following the bell curve, this kind of shape, that means in the first standard deviation, you will be having 65.45% of the data will be lying in this area. So what I'm saying is, if your data is following a bell curve like this, that means in the first standard deviation, negative side first standard deviation to positive side first standard deviation, 65.45% of the data will be lying. From the second standard deviation to second standard deviation, 95.45% of the data will be lying. 65.27, not 45. 65.27, 95.45. From the third deviation to third deviation, you will be having 99.73. Keep these numbers in mind. For example, imagine I have a column here. I have a column. Suppose this column, imagine if this column, if it is following this kind of distribution, so which means from the negative side 3 to positive side 3, this is the mean, first standard deviation, second standard deviation, negative side first standard deviation, negative side second standard. So it is following the bell curve, which means from the minus 3 to 3, how much data is lying, guys? 99.72% of the data is lying. So how many points will be outliers? Only 1 or 2. So this makes any effect for your algorithm? This makes no effect. Suppose if this data, if it is following this kind of representation, okay, do all the data is in the safe side? No. So what is the purpose of standard deviation is, you see here, for example, if I go here, normal distribution. Normal distribution means whether the data which is present inside the column is on the safe side or not. See, is on the safe side or not. if I represent the column like this, so if I represent the column exactly, if the column is coming like a bell curve, then my data is in the safe side. 99% of the data is in the proper way. Okay. So how, then what is the use here? Without a standard deviation, can you write the, can you make this plot? Can you make this plot without standard deviation? Impossible. See, every column should follow the bell curve. So for example, whatever the data that I created in the age, so in the age, so if I implement that particular, I mean normal distribution, let's say normal distribution, okay, a bell curve. So in the age column, so I think in the in the C1, we are having a visualization called this plot, this plot of age. So in the age column data, if I give to the this plot, so it is going to show you an histogram basically. So what I will do is, first I will decide the ELT dot figure of fixed size is equals to 5,3. So the visualization will be very small, looks good, but it's coming histogram. What we want, we need bell curve na?
Yep.
KDE. Kind KDE means kernel density estimator, which means bell curve. See guys, now tell me, do it is following any bell curve kind of thing? Let's say, let me reduce the height. See, do it is following the bell curve?
Yes, sir.
Little bit it is following almost, see? Yes or no? So most 70 to 80% of the data will be on the safe side only. 1 or 2 points will be outliers. So every concept will be having some meaning definitely. What is the meaning of normal distribution? If your column following the normal distribution curve like this, that says the entire data is in the safe side, or else you will be having outliers. Same thing if I apply on the changes, age changes column. See, now bell curve is coming or not properly. Why? Because previously you applied on the age where you are having outlier. Do you remember 27? In the age changes, I override that one. I change it. I handle the outliers. Now see, bell curve is coming or not perfectly.
Yes, sir.
Okay. So this is completely about descriptive statistics. An advanced level of descriptive statistics
Sir,
are there.
excuse me, sir. What is that kind is equal to KD?
Kind. So if you want to represent the kind, defaultly it will select the histogram. It will select the histogram. So I want the visualization. KDE means kernel density estimator, which means this plot showing the normal distribution.
Okay.
Okay.
Kind is
color also.
mandatory, sir. Kind.
Yes, kind. Kind means you are representing what you want.
Okay.
I need the kernel density estimator. So color what you want. I want the green color. See, if I give the green color, the green color line will come. Clear, guys?
Yes.
So completely about descriptive statistics. I will share this file in the drive. You can collect from there. And let's in the inferential statistics, I will just teach you one concept tomorrow, and we'll go with the SQL. So where is this inferential statistics? In the inferential statistics, we'll go with something like correlation, Pearson correlation and Spearman correlation, and hypothesis testing. All these concepts, I need to use the algorithms like machine learning algorithms. So then only we can implement the remaining things. Okay. So tomorrow we'll discuss correlation and we'll see the installation of SQL databases and all the things. Clear, right, guys? Everyone? Okay. So let me save it. Okay, you can check in the drives these files, guys. See you tomorrow, guys.
That's so. Thank you. Good night.